Hey Algebra 1, and thanks for tuning in. Today we're going to look at lesson 8.5 using intercept form. We're going to be looking for 5 things to go in our notes today, so let's go ahead and get started. First thing we're going to do is just warm up with something we learned in the previous lesson from graphing and standard form. Let's go ahead and try to find the zeros, y-intercept, and the vertex of this function, negative x squared plus 4x plus 5. So let's go ahead and take time now to pause here so you can try those 3 things, and then once you're done, click play to check your work. Alright, so what we can start off with is finding your zeros. Remember your zeros, you have to factor first and then solve. So what I did first is I factored out a negative 1 to make sure a was equal to a positive number. So I get x squared minus 4x minus 5. And then I factored out this formula right here, or this function, and I get the product of 1 times negative 5 is negative 5, which also equals negative 4 is a positive 1 and a negative 5. So I got x plus 1 as one binomial and x minus 5 as the other one, which means my zeros can be x is equal to negative 1 and x is equal to positive 5. So that's the first part. My y-intercept, remember y-intercept is always whatever c is equal to. So my y-intercept is 5 from this original equation. So I'd write 0, 5 here. And then my vertex, remember I can do vertex by finding my x value first, which is negative, and then b over 2a, and then plug that in and solve for y. So what I would do is just plug in b, which is 4, and then 2 times a, so that's 2 times negative 1. I'm going to get negative 4 over negative 2, which is equal to 2. So then I go back and plug it into my formula. Y is equal to negative parentheses 2 squared plus 4 times 2 plus 5. That's going to give me negative 4 plus 8, and then plus 5, which y would then be equal to 9. So my vertex is 2, 9. So that's just one way we're going to be seeing it. You could still use this way today because intercept form can actually be changed into standard form. So I wanted you to get warmed up with that. But this is what intercept form is going to be looking like. You can use it for quadratic functions to help you graph. We probably won't use this way as much as the other ways that we've seen, but it's still good to know how to use it. So intercept form is this in red, where you have a function f of x is equal to a parentheses x minus p times x minus q, and we kind of saw that here whenever we factored. A cannot be equal to 0, and the x-intercepts are always going to be whatever p and q are. With this form, we're just going to focus on finding zeros in the vertex, but we're going to use other forms to graph. So let's go ahead and take time now to pause the video here, and then once you're done, click play to see what happens next in number 3. So to review, we already know how to find the vertex by using this method. X is equal to negative b over 2a, and I'm actually going to make this negative b on the outside so it's a little bit easier to remember. What's new here, though, is we can find the average of p and q, so p plus q divided by 2, and that'll also help us find the x-coordinate, and then you would just use and find the y-coordinate the same way you did before, which is substituting and solving. So let's go ahead and pause and write this down. The new thing you especially want to write down is this right here, because that is directly related to intercept form. So let's go ahead and pause and write that. Remember to substitute and solve to find your y-coordinate. Once you're done, click play, and we're going to see how it's done. So what we're going to do now is going to try to find the vertex. So just remember, in the previous 2 pages, we talked about intercept form and what it looks like. We're going to try to use that here to find your y-coordinate. So let's go ahead and try that. I'm going to get you to pause the video, maybe try the p plus q divided by 2, and then once you're done, click play to check your work. Alright, so what I did here is I found what p is and I found what q is. So p is equal to 1 and q is equal to my apologies for the interruption. P is equal to 1 and Q is going to be equal to -2. It's almost like you're setting them equal to 0 and solving for x's. So that's why this format is really easy. Then I'm going to do P plus Q divided by 2 because that's what you wrote down on the previous page. So 1 plus -2 divided by 2 is going to give me -1/2. Okay, so that's my x value. So what I would do is then go back and plug it in to find y. So y is equal to -1/2 minus 1 times -1/2 plus 2. -1/2 minus 1, that's going to be -1.5. And -1/2 plus 2 is going to give me +1/2. So basically, +1 1/2. So basically what I'm doing is just multiplying. When I multiply -1 1/2 times +1 1/2, I get -2 1/4. So my vertex is -1/2, comma, -2 1/4. Now you still could have found it a different way. You could still do -b over 2a, but notice we don't have standard form. This is when it's written in standard form, but you can easily translate x minus 1 times x plus 2 into standard form by just foiling. And what that would look like would be x squared plus 2x minus 1x minus 2. So that'd be x squared plus x minus 2, and then you could use your b and a to find your x and then your y. This would just take a little bit extra steps because we're already in intercept form, and sometimes intercept form is where you're going to start, so it's good to know how to try this as well. So the last one we're going to try is writing a quadratic function in standard form whose graph passes through these 3 points. And what I've kind of already done for you here is labeled what each of the 3 points represent. So notice how the first two have an x value but no y value. That represents x-intercepts. And in intercept form, P and Q are always x-intercepts. The third point, we actually have an x and a y, so those are going to represent the other x's in your standard form. So we're going to use this right here to try to find a function. We're going to plug it in, solve for a, because we don't know what a is yet, and then once we find a, we can write maybe back in intercept form and translate it to standard by FOIL. So let's go ahead and try what we can first. Let's go ahead and pause here, and then once you're done, click play to check your work. Okay, so I know I'm just going to plug in what's given to me up here with these 3 coordinates. Y is equal to 20, A is unknown, X is equal to -4, and P is equal to -9. So I could write 4 minus -9, but that's going to translate to 4 plus 9. And then the same thing here. X is still -4, and then instead of minus -2, I'm going to say plus +2 with that other point. Now I'm just going to simplify the equation I have. So 20 is equal to A, parentheses 5, times -2. That's going to be 20 is equal to -10A, so that means A is equal to -2. Now what I'm going to do is go back and plug this in where I have f of x equal to that. So f of x is equal to A, -2, and then I'm still going to keep my P and Q the same. So x plus 9 times x plus 2. This is in this intercept form. I'm going to change it to standard form because that's what the question is asking. So what I'm going to do now is FOIL to change it into standard form. X times x, that's x squared. Outer will be 2x, inner is 9x, and last is 18. Still in parentheses, still be multiplying by -2 at the end. Now I'm going to combine like terms, so I have x squared plus 11x plus 18. And then now I'm going to distribute my -2 to everything inside the parentheses. So I'm going to have -2x squared minus 22x minus 36, and that is equal to the function f of x. So here would be my answer. Okay, so that would be how we would use intercept form to go to standard. Obviously we can go from standard to intercept form by unfoiling or factoring is what we actually want to call that. So that's going to conclude our notes for today. Thanks so much for tuning in, and we'll catch you next time.